Hello, my name is Sacha and I'm here to present a presentation on solar power plant which is designed for a 4 megawatt industry in Pakistan. The topic of my presentation is design and analysis of 4 megawatt solar power plant for industry in Pakistan. First of all, the introduction. Pakistan is a developing country due to current development and to accommodate its larger population industry. The country needs an enormous amount of energy to keep things on track. The rise in the price of crude oil and natural gas cause not only affect the lives of ordinary people but also damage the economy development of the country. All commercial sectors, including agriculture, industrial, transport, domestic energy generation, have been affected severely due to inflation and causing huge economic losses to the country. Huge dependency on fossil fuel not only has an implication for the national economy but also have led to several environmental hazards, greenhouse gas emission, global warming, CO2 emission, and irregular weather pattern. Moreover, government are encouraging for reducing for carbon emission and decreasing dependence on fossil fuel, affecting the demand for photovoltaic technology to rise instantaneously and significantly over the next few years. The main objectives that are considered before designing this always we have to design and do the cost analysis of 4 megawatt power plant solar power plant using Homer Pro. The second one is that the project that will not only simulate the solar power system, but we will also suggest the best selection of the equipment such as inverters and the other components so that our system operate efficiently and provide us good quality and pocket friendly energy. Third one is the project designed for umbrella steel, which will be available to save huge amount of money that is used to pay electricity for its power consumption. And after the initial investment, it will generate reliable power at comparatively low rates and environment friendly. The solar power plant design is based on efficiency, economics, and environment friendly. There are three types of solar system: standalone, which is also known as off-grid system; second one is the grid-tied, which is also known as on-grid system; third one is the hybrid solar system. The on-grid solar system consists of battery with an inverter, and it is independent of solar panel inverter. It is independent of battery, while the inverter is then connected to the house and or the grid. While the second one is the off-grid or solar system, which has the battery and it is independent of grid. In this type of system, the electricity generated is stored in battery, then it is applied to appliances. The third one is the hybrid solar system. It consists of battery and grid as well as the solar energy is converted into energy, then it is electrical energy, then it is stored in battery and then is applied to the home appliances. If the electricity generating excess quantity is transferred to the grid also. The major components of solar system are solar cells, panels, and array. The precursor element needed to design a solar plant or a solar cell. When sunlight strikes the panel, the solar energy is converted into DC energy, electricity. Usually, a solar cell has a voltage of 0.5 volt across it to increase the power and the cater for demand. The cells are connected in series and parallel combination. These cells are combined to form a module, and different modules combine to form a panel, and different panels combine to form an array. There are basically three types of panel: monocrystalline, polycrystalline, thin film. As it is shown the figure, the panel we select is the monocrystalline, manufactured by Trainer Solar. Its capacity is 500 watt. This panel selected based on the availability in Pakistan, as it has a good power output and it has a good power efficiency and the positive power. It's the positive power tolerance to 5 watt. There are some major factors that are considered while designing a solar system. The most important is the pitch or raw module distance. This is the distance between two solar panels, which should be the distance between the two solar panels should be set in such a way that there is no shading among them. The other one, the solar irradiance, which is uniform all around the place. The Another one is main one is the performance ratio, which is the ratio of the actual efficiency upon the theoretical efficiency of the solar panel. And the seasonal variation is the variation caused by the season, and the variations in solar panel caused by different seasons. Standard test conditions are conditions useful for performance of people at a specific cell temperature of 25 degrees C and irradiance of 1000 watt with air mass of 1.5 spectrums. The inverter is a major important part of the solar system. The photovoltaic panel generate DC energy, which is converted into AC energy, as all our load is operated on AC energy. And this is where an inverter is used. Inverter play an vital role when DC is converted into AC. The converted AC is then used by our appliances. This inverter classified into three parts: microinverter, string inverter, centralized inverter. The inverter we choose in this project belong to our technologies, which promises a good efficiency for commercial use. The inverter chosen is a string inverter because of its high redundancy, flexibility in faults, and space reduction and reduced DC cable loss. Here is a picture of inverter that we will use in our system. Now the main thing, the losses that should be considered designing, and the first one is the near shading. It is basically a shading loss due to lesser inter-row distance of between two solar modules. The second one is the irradiance loss. It due to lesser space between two consecutive rows. Some amount of irradiance in the morning and evening will not collected by solar cells, which is termed as irradiance. Third one is the albedo loss. Albedo is the reflectance of sunlight energy from the Earth's surface. The surface albedo reaches its maximum value in winter and its minimum value in summer. Yes, the main one is the LID, which is also known as light-induced degradation. It's occur when oxygen impurities in the silicon first react with P-type material in the first few hours of illumination of cell. This reduce the cell efficiency 2 to 4%. Array mismatch loss are function of production electrical uniformity. If there is no mismatching in the module, then there should be the electricity generation will not be uniform, which will result in loss. The third will be ohmic wiring loss. As the name implies, this loss is due to cable selection, representing the loss on DC in between module to inverter through DC cables. The other main loss is the inverter loss during operation. As the inverter convert DC into AC, electricity from DC into AC, there is certain amount of loss. This loss should be not more than 2%. Site we selected for this project is the steel industry. Dhabiji near Karachi. The area is an industrial area. Power shortage is not a problem, but the constantly rising prices of electricity are impacting financial and economic needs of the institution. There is a location of shown in the figure. The system is modeled in Homer, which is an optimization tool for renewables. Homer calculates energy balance, gives an optimized solution. The method used in this project in the design of solar power plant for industry includes photovoltaic panels, inverters, and grid. The photovoltaic panel generate DC energy, which is converted into AC from the converter. Then it's transferred to the load, and the excess of energy can be sold back to the grid. In this project, NASA Surface Meteorology and National Solar Radiation databases are used for daily radiation and clearness index. In Pakistan, the average solar radiation intensity is 5 kilowatt hour per meter square per day. The figure shows the radiation index along the whole year. As we know that the May and June are the peak summer months, so the radiation index is high in these months. After simulating on Homer Pro, we give you the results are obtained as predicted. It is clearly shown that the PV serves the maximum load and the grid acts only backup source of generation. The emission and loss of solar power plant in the show, which shows the a large amount of carbon dioxide and other gases are reduced by implementing the solar project. As we know that the two points, as it is shown that the 2.7 million of carbon dioxide 2.7 million kg per year of carbon dioxide will be reduced by implementing this solar technology, and the large amount of sulfur dioxide and nitrogen oxide is also reduced, which is very dangerous for health. The cost size of the system is component is shows. As we know, the sustainable systems are prioritized based on the net present cost of the for industry. The main concern people is the cost, which is also considered while selecting any optimum system. As it is shown from the figure that the system will generate implement initially the cost of the system will be 7.4 million dollars, which is a very huge cost, but in a span of 15 years and depending on the current rate of the grid electricity provided by the grid, it will take up say around 700,000 dollars in the span of 15 years. But as we know that the price of the grid will increase depending upon the oil prices, is so our profit will also be increased in respect of time. A solar plant, now the conclusion, a solar power plant is designed this project for the Ambeli steel plant. Solar resources are bargained, so the proposed microgrid system consists of photovoltaic panels and the grid acts as a backup. The model includes a converter and solar panel. The data of solar temperature taken from NASA surface meteorology. The design system is optimized based on sensitivity, techno-economic analysis, emission and cost of energy. The cost optimization is performed for finding the most feasible and optimal system based on the net present cost of the least cost of energy. That's all from all my project. Thank you.